Welcome to Introduction to Maya series. I am your instructor Rohan Page. In this video, we will understand the types of rigid bodies available in Maya. What will be our workflow? First, we will see active rigid body and its attributes. Then we will see the passive rigid body and how we can use it. We will also see the types of constraints which are available for rigid body. Let's start with the session. Let us know how a rigid body can be created and how it gets simulated in Maya. First of all, change the menu set to dynamic so that you can get the options of soft rigid bodies. Click over here, you will get the window of the soft rigid body. There are two types of rigid bodies. One is active rigid body and other is passive rigid body. How they work? So let us see how they work. First of all, create any kind of object, a polygon surface which I am creating in a 3D scene. Okay. So select the object which you want to convert into active rigid body. Then go to option and convert it into active rigid body. Basically, active rigid bodies can be simulated, they get affected because of fields, they can get collided. So this is about active rigid body in a brief. So select it, you can see the attributes of translate, rotate for that selected object can be displayed in yellow color, which means they got converted into active rigid body. You can see the attributes of active rigid body in its input channel, where you can see there is a rigid body 1 option. Click over here and you will get lots of options for that rigid body. Now if I'll play, there is no as such any kind of a simulation happening on the screen. You can either apply field or it has inbuilt option which has the ability to generate simulation. Now select this object. Go to rigid body option from channel box. There we have option of initial velocity. Now initial velocity in X, Y and Z, it can be used to accelerate this respective object in any of the axes mentioned over here. So suppose if I am mentioning a value of initial velocity in X direction, that is 5, it means that objects will travel 5 units in positive X axis per second, that is per 24 frames. So play it and you can see there will be a constant movement in this cylinder which is accelerating this object in positive X with 5 unit per second speed. You can mention negative value also. It will move the object in negative X axis with minus 5 unit per second. You can use initial velocity in Y or Z according to your requirement. You can mention the value and it will move in that respective direction. So I'll keep the value of initial X to 5. After that we have an option of initial spin X, Y, Z. So you can add a rotation in these X, Y, Z axis. If I'll mention, for example, before mentioning the value, I would like to check the rotation. So this is a Z rotation. If I want to rotate like this, so it is a Z rotation in negative axis. So I'll go back to initial spin. Initial spin Z and mention the negative value of around minus 50. It means that object will get a progressive rotation of minus 50 degree per second. That means it will take 25 to 24 frames to get rotated in negative 50 degree angle in Z axis, and the next frame it will get rotated progressively with the same offset, that is minus 50. So just play it and you can see the effect. Now increase the spin to 360 per second, one rotation per second. So you can see how it is behaving. Okay, so these are the few attributes which can generate a basic simulation without any kind of a field in this respective rigid body. Now let us see how we can use active rigid body and passive rigid body with field. Create a basic polygon plane. I would like to use it as a floor. Okay, now these are the steps. I'll just rename it like floor and rename this as steps. I will create one object, again a basic cylinder. Select this respective object and convert it into active rigid body. Now I would like to apply a field. So select the object, go to field, gravity. Now this active rigid body is falling in downward direction. I want this object to get collided with these two. So there is other type of rigid body which says passive rigid body. It works as a collision object. It do not get affected because of any kind of field. So select the objects which you want to convert into passive rigid body, then go to soft rigid body option and choose passive rigid body. Now play it. You can see that it is getting settled down on that respective steps. So use few options so that we can change the overall simulation effect. Select the active rigid body. I will have a little bit of push to this respective object in x-axis with 2 units. It will move and add initial z rotation minus 10 and just see how it gets affected. Check it out as it is not getting the initial spin. Check out which axis it needs to get rotated in channel box. It is negative z itself. So the initial push I would like to give 0.5 unit, whereas initial z minus 50. We have few other options which we can use to change the overall simulation. If I'll reduce the bounciness 0.2 and damping 0.5, you can see it has reduced its bouncy effect and it looks like a heavyweight object. I'll reduce the damping value to 1, increase the bounciness to 0.8. You can see how it is affecting now. increase the mass, and reduce the bounciness, increase the damping. You can see it is not even falling because of the overall mass has been increased. Damping will slow down, or you can say add a more resistance to the object. We can have few more example of this active and passive rigid body. For that I'll create again a basic floor. Select the floor, convert it into passive rigid body. Select this object, convert it into active. Also these boxes I would like to convert into active rigid body. Now there is no simulation as I haven't applied any kind of acceleration, velocity to the surface, or neither any kind of field is working. So select the active rigid bodies basically and apply gravity field. Now you can see how these are getting affected. Okay. Now select it. I will have the acceleration in initial velocity x with the value 5, or you can add 10, the more speed. You can see how it is going to get collide. Okay, I need to change the overall placement of the ball. Right, so increase the speed for a greater impact. You can increase the speed to 30. Just check it out how it affects. If I am reducing the velocity to 15, you can even select the sphere and increase its mass value to 10, velocity value to 25. Now you can see how it is affecting overall the overall boxes. So select it. If you want to add little bit of you can reduce the bounciness to 0.1, increase the damping to 0.5. So there will be a friction added into the simulation. So this is how active rigid body is going to work in Maya. There are few constraints which we can see for the active rigid body over here: nail, pin, hinge, spring. So how they work. For example, I have created this sphere. Duplicate it. Select all and convert it into active rigid body, and then I'll apply a gravity field. All the objects are falling down. Now if I'll select this active rigid body, go to soft rigid body, create a nail constraint, and just move it a little bit in upward direction, you can see that all other active bodies are falling down, whereas the active rigid body which is constrained with nail is not at all falling down. So nail constraint is going to hold an active rigid body so that you can later on use any kind of channel attributes and have different kind of simulation. So now the active rigid body is now is holded by the nail constraint. So I'll just select all other and apply same nail constraint one by one. Use G to execute the same command. Now all the active rigid bodies are on hold. So I'll just select this one and add initial velocity in minus direction. See how it is going to get simulated. It will try to move in negative x, but because of nail constraint, it will not be able to move further, and gravity will attracts it toward downward direction. So this is how nail constraint works. Let us see the next type of constraint, that is pin constraint. You can apply pin constraint between two objects. Those can be active rigid body or passive rigid body, or one active, one passive rigid body. So as nail constraint can be applied with only one object, you will need two objects for using pin constraint. So create a basic example. Okay, now I'll just select this one and convert it into active body and apply gravity. Play the simulation. It is going down. Now I'll select the first one and convert it into active rigid body, passive rigid body, because I don't want this object to get affected because of gravity. Now I want to animate it. So when it is a passive body and you want to animate a passive body, then there is one option called as set a passive key, which is going to set a keyframe for a passive body. So set a passive key, you can see the red mark over here at the frame number 1. Go to frame number 30, move it, set a passive key and move. Change the keyframe. Now select these two and apply pin constraint. You can see there is a connection between two objects. Press G to repeat the command and see how it is going to create a simulation. It is behaving like a dynamic chain. Right. So this is about pin constraint. The next constraint is hinge constraint. So let us see how it works. Select the object, go to Hinge, sorry, but before that convert them into active bodies, and now apply a hinge constraint. I'm moving this hinge at this side. Press G to repeat the command. You can see how the constraint is getting created. Hinge is going to hold this object in the direction as mentioned. So wherever you will place this hinge, it will get a hold from that axis. Now I'll select this active body and I'll apply gravity only to that sphere and see how it is getting affected. Those all the planks are having a hinge at one side. Okay, so this is hinge constraint, and the next one is spring. Select the basic object, that is sphere, go to soft rigid body, apply spring. If I'll play, there is no such simulation happening over here. I'll increase the number of frames. There is an option called as spring rest length. You need to use any kind of a value. If I say 3 units, so it is going to push that object 3 units away from the center, and it behaves like this. If I increase to 5 unit, it will get pushed away from that center 5 units. You can increase the stiffness to around 18 and play how it affects. If I'll increase to 35, the overall simulation is getting a speed over here. The push it is getting is more. Increase the damping value to 0.5. You can see that it is resting to the it is resting very early. If you are increasing the damping, it is reducing its flexibility basically. Okay, so with the help of this active rigid body, passive rigid body and the constraint, we can create one example of catapult. So create a basic scene over here. This is a floor. Insert these edges, extrude, extrude it inside and extrude. Freeze the transformations. Now this is going to be your catapult. Create one sphere. This will be the object which needs to be get thrown away from this catapult. Select this both objects and convert it into active. Select this one, convert it into passive. Select these two active bodies and then apply gravity. You can see that these objects are going to fall down on the ground. Right. Now use the constraints. Select it, apply hinge constraint, and play the simulation. Now I need something which is going to push away this catapult. So select it and apply spring constraint. Go to side view or front view according to the requirement. You need to push this catapult from exactly from this side. Now if you'll see, it is not creating any kind of effect. I need to change shift the mass of the object at this area so that I can get a proper spring movement. Select this active body and change its center of mass in X direction. Just select the option, hold control on keyboard and middle mouse drag. Okay, still there is no effect because we need to work on the spring rest length, which is 0. I want to push it away. If I'll add a 5 unit, it is not going to create that effect. So we will have to use a greater amount, like around 50 units. Just check it out. Now you can see that how it is throwing that sphere. Use it to around 85. Increase the stiffness to 50. It is increasing the overall speed. I'll just make it to 10. Or 1. So it is throwing that ball in this way. So you can use spring nail to throw the ball with the help of catapult. So in this way we have used this constraint and active and passive rigid bodies. So let us see what we have learned in this video. What we learned in this video. We have seen that there are two types of rigid bodies in Maya, that is active rigid body and passive rigid body. We have seen that active rigid body can get affected due to fields, whereas passive rigid body acts as a collision object. We have also seen that there are nail, pin, hinge and spring constraints which are available for rigid body. We have also seen how we can use it to create a catapult example. For any query, you can follow me on Facebook. You can write me an email on rohan.pagianimator@gmail.com. You can subscribe to my YouTube channel or you can join the Google Classroom with the following code. Thank you.